In this lesson, we're looking at triangle proportionality. So triangle proportionality theorem says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the segments into proportional lengths. So if DE is parallel to AC, then we have two situations here. BD, the section BD compared to DA, so BD to DA is equal to the ratio of BE to EC. Now, if you notice here, I've got these highlighted in blue here, or I've written them in blue. What I've done is I've swapped, okay? I just changed, because if you cross multiply these, we know they'll be equal. If I just, it doesn't matter the order I multiply them, so I can bring DA to the bottom and BE to the top, or vice versa. And that gives us the relationship with the top. So that means that if we're looking here, we have the relationship between BD to BE, as well as, let's see if this will show up here, maybe in a different color here, DA to EC. So you can kind of separate it from the top and the bottom, so you can do a relationship with the top segments to the bottom segments. Or you can set it up like your fraction here and let this be your fraction line, and you have the top BD to the bottom DA equal to, put an equal sign here, you got the top BE to the bottom EC. So a couple ways to work these depending on what information you have. So the converse just says if BD is proportional to DA and is equal to BE over EC, then DE is parallel to AC. So let's take a look here at some problems, and we'll kind of show you how this works. Now, so like I said here, I'm going to work it both ways, and it really doesn't matter which way you do it. So sometimes I will break it up between, like, kind of, if I say this is my fraction bar here, top over bottom. So I could say 14 is to x as 12 is to 15. Because these lines are parallel, it doesn't matter the order I work it in. So I can do 12x equal to 14 times 15. And let's see, that's going to give us 210. Okay, and we divide by 12, and x is equal to 17.5. Now, if I work it a different way here, if I said these segments here, if I said 14 is to 12 as x is to 15, notice that 14 and 12, that 14 would be using the whole side of this triangle here, and x over 15 would be this other side of the triangle. Notice that 14 and x are in the same kind of set of parallel lines here. So that means that it's going to be, we can put 14 and x on top and 12 and 15 on the bottom. So when we cross multiply, we notice we're still getting the same results, even though these have just changed places, the 12 and the x. So we get 12x is still equal to 210. We divide by 12, and that gives us that x is equal to 17.5. So just depends on how you want to look at it. You can work them both either way. So let's take a look at the next one. So we have this segment's 18, we got x, we got 56 and 21. So we can break this apart as, like I said, either way is okay. You can say 18 is to x as since we did 18, that means I'm going to have to go 21 is to 56. So remember, this section, it's kind of like you're in between this section here. The 18 and 21 need to go together, either one over the other, or both on top or both on bottom. And then you can cross multiply. Now you could also simplify these 21 and 56, but you can also just cross multiply here. So we get 21x is equal to 18 times 56, which is 1008. And then divide by 21. And x is going to give us 48. So try the next one here. Okay. We got this section here, we got x and 36, we got the full length of 55, and we got 45. So pause your video and check your answer when you're done. So notice here that we have this full length here, but we don't know what this segment here. So if we take this 55 and subtract 45, that gives us 10. So that little segment is 10. So now we can say x is to 36 as 10 is to 45. cross multiply, you get 45x is equal to 360. Divide by 45. And x is equal to 8. Okay, so hopefully you can see what we did here. And the next one here, we have the full length of 27. We have this segment 6, so if we subtract it, we get this segment as 21. So we can say that 7 is to x, as since we did start with 7 on top, we got to go 6 is to 21. And then cross multiply, we get 6x is equal to 147. Divide by 6, and that gives us x is 24. All right, so pause your video and now let's try number 5 and 6. All right, let's see how you did. So we have 30 over x plus 7 equals 25 over 15. Now you could also reduce this to be by 5 to become 5 over 3 to make it smaller numbers to multiply through. So you get 25 times x plus 7 equals 30 times 15 when we cross multiply. 25x plus 175 is equal to 450. We're going to subtract 175 from each side, and that gives us 25x is equal to 275. Divide by 25 and gives us x is 11. Now, the next one over here, we can set it up as 6 over 21. So it's like putting a fraction bar here and here and setting them equal. So 6 over 21 is equal to x minus 1 over 3x plus 1. When we cross multiply, we get 21 times x minus 1 and 6 times 3x plus 1. Distribute the 21 through here, which gives us 21x minus 21, and it equals 18x plus 6 as we distribute the 6 through the parentheses. Going to subtract 18x from each side and add 21 to the other side. So now that leaves us 3x on the left and 27 on the right. Divide by 3, and that leaves us with x equals 9. So now let's look at the next part. It says determine whether these lines are parallel. Well, in order to do this, the easiest is we're going to set up our proportions and see if they're equal. So we can do this a couple ways. We can do 11 over 15.4 is equal to 10 over 14. Now we can try to reduce this and see if they're the same, or you can cross multiply. So if we cross multiply, we get 15.4 times 10 is 154. And then we do 11 times 14, that's going to be 154. They're the same, so therefore, yes, these are parallel. All right, let's look at the next one here. So we can do this a couple ways. We can say 4 is to 5 as 15 is to 18, or we can say 4 is to 15 as 5 is to 18. So either way, we can set this up a lot of different ways here. We'll just set it here over here. There's our fraction bar, so let's do 15 over 18. Let's just make it easy, and 4 over 5. Okay, so this one looks like we could possibly reduce this pretty easily. So let's see here. 3 goes into 15 5 times, and 3 goes to 18 6 times. Is 4/5 equal to 5 6? And that is no, so the answer is going to be no. These are not parallel because they're not proportionate. Now this last one here, we have 24, we have 30, 30.7, we have the whole length of 54. So if we subtract this, this is going to give us 30 for this segment. So we can now say 30 over 24 is equal to 37.5 over 30, and then we can cross multiply. So as we cross multiply here, we get 30 times 30, which is going to give us 900, and we get 24 times 37.5, that's going to give us 900, so therefore, yes, these are parallel. All right, just a quick way to check if they're parallel. So now let's look at what happens with parallel lines and proportional parts. So if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. So if AB is parallel to CD, which is parallel to EF, then you get the following proportions. And this is very similar to what we just did. It's just we don't have a triangle here. If you just connected these a little further, you would have a triangle. So the length from AC is proportionate to CE. and BD is proportionate to DF. Now, you can also say that you can go across and say AC AC to BD is equal to CE to DF. So just like the last one, there's a couple ways you can set them up and still get the same correct answer. So let's look at number 10. We look at this one here, we can say 45 is to 18 equals 52 over x. We cross multiply here, and that's going to give us 45x equal to 936. Divide by 45, and that's going to give us 20.8. All right, and let's look at our next one. So we can say here 12 is to 30 equal to, now since we put 12 on top, we got to put 14 on top, and we're going to put x down here because these two kind of go together and these two go together here. These have a relationship and these have a relationship. So that's how we can always know to set these up here. Cross multiply, we get 12x is equal to 30 times 14, which is 420. Divide by 12, and that's going to give us x is equal to 35. All right, let's look at number 12. Notice here we got 32, so we need to figure out what this segment here is, and that's going to be 14. So we can set this up either a lot of different ways, and I think it's easier if we just know that one's on top of the other here. We can say 27 is to 18, which gives us our fraction, and x is to 14. Cross multiply, we get 18x equal to 27 times 14, which is 378. And then we divide by 18, and that's going to give us x is equal to 21. So you guys try number 13. So pause your video and come back and check your answer when you're done. All right, so once again, hopefully you saw you need to subtract. So 92 minus 28, that's going to give us 64. And so now we can set this up as 28 over 64 is to 31.5 over x. So sometimes it's easier just to let the picture dictate how we set these up. So 28 times x is equal to 64 times 31.5, and that's going to be 2016. Divide by 28, and that's going to give us that x is equal to 72. All right. Why don't you guys try number 14 and 15 again and come back and check your answers when you're done. All right, so hopefully we saw that we're going to have 24 over 18 set up as 3x plus 1 over 12. Cross multiply here, we're going to have 18 times 3x plus 1 equal to 24 times 12. Next step we're going to do here is we're going to distribute here, so 18 times 3 is 54, x plus 18, and then 24 times 12 gives us 288. So once again, you could have simplified 24 and 18 to use smaller numbers, or you can just leave them as they are. So we're going to subtract 18. 54x is equal to, that's going to give us 270. And divide by 54, and that gives us that x is going to equal, let's see here, 270 divided by 54, we get 5. So x is equal to 5. All right, let's look at our last one here. So we're going to take our setup here, we're going to have 2x plus 2 over 21 is equal to x plus 3 over 12. Cross multiply, we get 21, or excuse me, let's do the other one first. We'll go 12 times 2x plus 2 equal to 21, reverse that, times x plus 3. Distribute 24x plus 24, 21x, and there we go, mixing things up again. 21x plus 63. So now we're going to subtract 21x. That's going to give us 3x. We're going to subtract 24. So 63 minus 24, that's going to give us 39. Divided by 3. X is equal to 13. All right, so that concludes our lesson on triangle proportionality.